Alright, so looking at that warm-up, on the top ones you're factoring, so they are all quadratics. So you would look at that last and the first and you'd say, okay, are there factors of 2 that get me to the middle? If that is true, then that means that it is factorable. So 1 and 3 were both factoring with a values greater than 1, which meant that you were going to have a value on one of your x terms and a fraction for an answer. 2 and 4 are both examples of difference of squares. So in 4, you had to take out a GCF of 10 to see that difference of squares. So we begin this focus and this unit review with factoring because as we work through the problems in this topic, you are going to have to factor through simplifying. So all those techniques of factoring are going to come back into play. More than likely it's going to be quadratics, difference of squares, perfect square trinomials, and GCFs. The second half of the warm-up has to do with multiplying and dividing fractions because that's going to be the other aspect of what we're doing. We're going to multiply and divide expressions. So when multiplying fractions, the rule is that you multiply straight across. So when multiplying fractions, you multiply straight across, and then if possible, you simplify. So obviously in number 5, when I would multiply that one straight across, I would have 15 over 48, so 15 and 48 divided by 3, giving me the 5/16. When you are simplifying through division, you have to take the second term, you flip it, and then you multiply. So I'm trying to get my writing utensil to pop up for us. But you take the second term, you flip it, and then you multiply straight across. So this would be like 5 times 1/4, which gives you the 5 over 32. Questions, comments, issues, concerns? Okay. So then let's get into what we're going to look at today. So our focus today is going to involve both of these topics, but at an accelerated level. So if a scuba diver goes to the depths greater than 33 feet, the rational function t of d is equal to 1700 over d minus 33. This gives the maximum time a diver can remain at those depths and still surface at a steady rate with no stops. T of d represents the dive time in minutes and d represents the depth in feet. So what does the term rational function imply? So why do we need to know what the word rational means? So in mathematics, the word rational is another way of saying a quotient and if we think about the word quotient, quotient goes hand in hand with the word fraction. So a rational function is a function of fractions. A rational function is a function of fractions. where it is a function made up of two expressions that are fractions. And then this follow-up says, what is the ratio in this function? So the ratio is the numerical part to it. So it would be 1700 on top to 1 on bottom. So the ratio is 1700 to 1, and then the functional part is 1 over d minus 33. So the ratio is the numerical aspect times the function. So we're jumping all the way to chapter 9. We're looking at rational functions and rational expressions because this is an aspect that you will need to utilize and apply throughout pre-calc and calc. So our goal is to simplify rational expressions and to eliminate what we refer to as complex fractions. Now, a complex fraction is not a complex number. It simply means multiple fractions and expressions. So like I said, a rational expression or a rational function is a ratio of two polynomial expressions. If you think about the word polynomial, polynomial means it has a domain that is all reals. So polynomials have domains that are all reals. But what do we know about a denominator of a fraction? A fraction's denominator can never equal, if we never divide by a math, 0. So we have to bring back and recall domains because we can never divide by 0. So that's again where polynomials, solving them, it all comes back into play. So the directions are going to be pretty simple. I'm going to say simplify. So the goal is to do just that. You want to simplify. So take your numerator, write it in factored form. So x squared plus 4x plus 3 factors as x plus 3, x plus 1. The denominator factors as x minus 6, x plus 3, x minus 3. So what do you notice happens? In both the numerator and the denominator, I have x plus 3. If you have the same thing on top as you do on the bottom of a fraction, what can you do? Cancel them. X plus 3 gets removed. It is simplified by removal. Removing it also removes it from our domain though. So that will create what we call on our graph a hole. So now x plus 3 cannot equal 0 anymore, meaning that x cannot be negative 3. It removes x equals negative 3 from my domain. So when we talk about domains, we have gotten rid of negative 3. Now I have 5x, x plus 1, over x minus 6, x minus 3. Nothing else can be simplified, nothing else can be canceled. If I finish my domain, we know that the denominator cannot be 0, So anytime the denominator is equal to 0, we will have what we call a vertical asymptote. That's where there's like this line on your graph. So you're going to have a vertical asymptote when x minus 6 equals 0, or when x equals 6, and when x minus 3 equals 0, or when x equals 3. So my domain has become all reals except -3, 3, and 6. We're not graphing. Agreed. We're not graphing. What I do want to know pulls vertical asymptotes to get to domains. And all you have to do is worry about the denominators and cancel. So, sorry, my follow-up, I did it all on one page. Under what conditions is the expression undefined? It is undefined under these conditions here. Just like circle it, throw an arrow down, or just cross it off. But that is where it's undefined. It's undefined where the domain does not exist. Okay. Same idea, same concept. This time my numerator is already in factored form. So I'm going to look at the denominator and say, all right, what can I do, if anything? So does y squared minus y minus 6 factor? So the last term is negative, the middle term is negative. That means one term has to be each side. So then you need factors of 6 that are 1 apart and sum to -1. So -3, +2. So now, when I look at this problem, I have y dividing y factored out. So if you have y over y, the y's cancel. The minute you cancel your y's, you created a hole. Or you removed 0 from your domain. You have y minus 3 and y minus 3. Goodbye. So y equals 3 is another hole. So all that means is that if you were to graph this on your graph, you know, like on piecewise where we have holes on our graphs, these would be holes. That leaves me with the new function 4, y plus 4 over y plus 2. The denominator creates your vertical asymptotes. So I have a vertical asymptote at y equals -2. Therefore, to follow that, under what conditions is this expression undefined? My domain would be -infinity to -2, not including -2. -2 to 0, not including 0. 0 to 3, not including 3. 3 to infinity. The conditions on which it is undefined is anywhere that denominator would equal 0. What's happening are the holes and the vertical asymptotes. A vertical asymptote is where your graph has like a little dashed line straight up and down. That's like what you would see. So it's like going down, it's going up, and then it's zero, like there would be a hole, and then let's say it goes back up again, there would be a hole in your graph at 3 as well. I have no idea if that's what the graph actually is, but like you would see holes on your graph. Or if you put the original or the simplified into your calculator and you typed in 0, 3, or -2, it's when your table would say error. So if you don't get error on your calculator. There are going to be times when you have to take out a -1 to make your factors match. So let's say, for example, I had -x plus 4 over x minus 4. If you take a -1 out of your top, are these now the same? Yeah. So that's what I'm saying when I say to simplify taking out a -1. Sometimes if you take out a -1 or you from a problem, then they match. So you just want to make sure you look for that. You want to look for opposite signs to cancel. So 4w squared, 3wy. We're going to take out a w, leaving 4w minus 3y, w plus y. And then if you look at your denominator, that has -4, so that's the opposite of my +4. It has +3, that's the opposite of my -3. So that's a case where if I take a -1 out, I now have a +4w and a -3y. Thus allowing me to remove 4w minus 3y from my problem, making my new answer w plus y, -1, 5w plus y. You can leave the -1 in your denominator. You can also move it up and put another w in the numerator. Both are correct. Both are fine. This one and its conditions under which it's undefined are a little bit more unique. Your answer is not going to necessarily be like an x equals or a y equals by itself. X and y are going to depend on each other, or wy are going to depend on each other. So it has a whole when 4w minus 3y equals 0, or when 4w equals 3y, or you could say when w equals 3y divided by 4. Those are all fair conditions. And then it will have a vertical asymptote when 5w plus y equals 0. And again, you could say when w equals -y over 5. But the conditions for which it's undefined are a little bit more unique. For your homework, you only have to do it for one variable problem. So I don't have to do it for 2 variables. Your homework will do that back and front